When I look at this problem, I see it's an equation with an equal sign, and the directions say solve. So that means I'm supposed to find any value or values that make the equation true when substituted for the variable x. Since this is an equation, I can multiply both sides by whatever expression I choose. And since there are fractions, it would make sense to multiply by the lowest common denominator so that I can clear the fractions in the problem. Now the lowest common denominator has to contain any factor that's part of an original denominator. When I look at the first denominator, x minus 4, that's a minus, so that's not a multiplication problem. Those are not factors. So the whole quantity, x minus 4, will have to appear as part of my LCD, my lowest common denominator. The second denominator, x squared minus 4x, again, that's a minus. Those are not individual factors, but that denominator can be factored because there's an x in both terms, so I can factor out an x. So when I write this down, then I'm going to leave the first fraction alone. And then the second fraction, I'm going to factor that denominator. So I'm going to pull out the x and then sort of play what's missing. X times what would be x squared? That would have to be another x. X times what is negative 4x? Well, that would have to have the negative 4. And then I'm just going to have the 2 at the end. So my LCD has to contain the whole first denominator, x minus 4, and then the second denominator, its factors as well. So an x and another x minus 4, but I really don't have to put the x minus 4 down twice. If I make my LCD just x times x minus 4, notice that the first denominator, x minus 4, is part of it, and the second denominator is also part of it. So both individual denominators are part of my LCD. That's what I want. So now I'm going to multiply both sides of the equation by that LCD. Since there's a minus on the left-hand side in between the fractions, that LCD then is going to have to get distributed to both fractions. Since they're fractions, I'm going to write it over 1, just to make it a little easier to see. So what I'm going to get then here, I'm going to take x times x minus 4 over 1, and I'm going to multiply by my first fraction, 1 over x minus 4. Then I'm going to do the same thing with the second fraction. And then over here, I'm not going to have to write the x and the x minus 4 over 1. It's just all multiplied together. So now we see that there's some canceling that's going to happen. In my first fraction, the x minus 4's cancel out. In the second fraction, the whole numerator and the whole denominator cancel out like that. And then, of course, nothing happens on the right-hand side. So what am I left with here? Well, I've got x times 1, so that would just be 1x. And then I've got minus, everything's dropped out here. 4 times 1 is just 4. And then over here I would distribute 2x times x is 2x squared. 2x times negative 4 is negative 8x. So at this point, I realize now I've gotten rid of the fractions. That's what the LCD does. But I have to solve this equation that's left for x. And what's really important here is that I've got an x squared. See that over there on the right, 2x squared. That means this is a quadratic equation. I can't just get x by itself as easily as a linear equation where I just have x to the first power. So to solve a quadratic equation, we have to get the whole equation set equal to 0. Now, I like the fact that it's positive 2x squared, so I don't want to move the 2x squared to the other side or it would become negative. So I'm going to leave everything on the right and get 0 on the left. So I'm going to move the 1x over, or just x. So I'm going to subtract x from both sides. If I do that, then I'm just left with negative 4 on the left. And we're going to get 2x squared minus 9x on the right? Negative 8x and negative 1x gives me negative 9x. Now I'm going to get rid of the 4, that minus 4, so I'm going to add 4 to both sides. And so what happens then, I'm left with 0 on the left I get 2x squared minus 9x plus 4 on the right. Now I've got that quadratic equation, it's got an x squared. There are no common factors there. X is only part of the first two terms. 2 goes into the first and the third, but not the second. So I've got to try to factor this trinomial into two binomials. So what I do is I make my parentheses, and I sort of do trial and error a little bit here. Now, fortunately, the 2x squared, there's really not a lot of ways to break that up. I'm going to have x times x for x squared, and for the 2, I'm going to have 2 and 1. So I could just break this apart, 2x times x. If you wanted to put the x first and the 2x second, that would be fine too, but this way will certainly work. Then I've got a plus 4, so I'm going to have either two positive numbers or two negative numbers in this last part of the parentheses. And it's going to have to either be 4 times 1 or 2 times 2. Since they're both going to be plus or both going to be minus, they're going to add together to equal that middle. And so I noticed that if I would have the 4 times the 2, that would give me 8, which is pretty close to 9. So I might try putting the 4 over here so that when we multiply the inside and the outside, the 4 times 2x is going to give me 8x. And then I notice, well, yeah, 4 times 1, if I multiply 1 times x there, that's going to give me 1x. And if I make those both negative, then that's going to work. That's going to give me the negative 8x and the negative 1x, which will give me the negative 9x up there. So now I've factored this. I want to set each factor equal to 0. The only way to multiply and get 0 is if one of the parts was 0 to begin with. So I would get 2x minus 1 equals 0, or x minus 4 equals 0. So to solve this, I'm going to add 1. That gives me 2x equals 1, and if I divide, I get x equals 1/2. Over here, I'm just going to add 4. So that gives me x equals 4. And both of those are possible solutions. Since this was an equation, a rational equation, the variable appeared in the bottom, in the denominator of one of my original fractions, I have to make sure that neither of these solutions makes any of my original denominators equal to 0. It's usually easier to look at this in the factored form, so sort of the second line in this problem up above. If I put in a half in the first denominator, I get a half minus 4. Well, whatever that is, it's not 0, so that's okay. And if I put it into the second denominator, I get a half times a half minus 4. Well, again, I don't know what a half minus 4 is, but a half times something that's not 0, that's not going to be 0. So if I plug in a half, I don't get 0 out in any of the denominators. So that means that's probably one of my solutions. Notice, though, that the 4 gives me trouble. If I plug 4 in just to the first numerator, 4 minus 4 is 0. That's not valid, so I have to discount that as a solution. So this equation really only has one solution, x equals 1/2.